Good afternoon, Earthlings. Welcome to another virtual tour of outer space. My name is Josh. I'm part of the staff at the Morrison Planetarium. We are bringing a very special program to you in your house. We are flying you around our solar system, seeing some really cool stuff through the OpenSpace software. OpenSpace is a planetarium software like a couple we use in our dome, but this one does something really cool. It doesn't have a big price tag associated with it. This is a software you can download and use yourself. Just go to the OpenSpaceProject.com. You can check it out and do the exact same tour I'm doing. So with our virtual tour of outer space, one of the coolest things about it is I'm the pilot, but you are the captain. You get to tell us where we're going, what we're doing, all the things we should be checking out. If you have a favorite place in our solar system, someplace we absolutely have to see, drop it in the comments and I will do my very best to pilot us out there. We're going to be flying around talking about some stuff, and if you have a question, similarly, I will do my best to answer it. So we're starting our virtual tour of outer space in outer space. This time we are looking at our solar system sort of from around the orbit of Uranus. We're pretty far away, and you can see almost all those blue lines showing us where our planets are around the sun. Now, checking out our solar system like this, we're going to take a pause, and just for a second, notice the things that aren't in our solar system. Check out these stars over here. That's the constellation Orion. Now, if we fly in, we should be able to tell from our position on Earth, assuming all of you live on Earth, which usually is a pretty good assumption, where the sun would be in relation to Orion. Looks like the sun is pretty close to where Orion is, maybe a little bit off. So Orion should be visible in our sky. Constellations that are really close to the sun tend to be invisible because the sun makes it hard to see them. And if you want to find out more about the cool stuff you can see in our night sky, including a comet, you're going to want to tune in tomorrow for Bing Kwok's broadcast. He's going to be telling us about the stuff you can see in our night sky. He's actually producing for me right now, so he's behind the scenes. But we're going to start a tour of our solar system by looking at some of the cool stuff traveling around our sun in those nice predictable orbits, as well as the sun itself. When we talk about a solar system, you got to have a star, a solar, to have the system going around it. Now, looking at the OpenSpace software, you can see a simulated image of the surface of the sun. This isn't the kind of thing you can go outside and look with your eyes to confirm, though. Looking at the sun is never a good idea. It can really hurt your eyes. But there are specialized telescopes, including some in space, that can take images like this, showing us what the sun's surface is like. Now, I hate to tell you, this is actually a little bit dramatized version of the surface of the sun. If you check out the SDO, the Solar Dynamics Observatory right now, you can see the sun is actually a lot more boring than this. Right now, our sun is almost completely featureless. We've got very few sunspots, very little flare activity. It looks kind of dull. So the sun looks a little jazzier in our software just to make it look extra interesting. Now, when we're talking about our sun, it is a dynamic place, a place that is always changing. When we talk about the rest of our solar system, some spots are changing day to day. Others look pretty much the same. One of the most static, unchanging spots in our solar system is this thing right here. This would be Mercury. Now, why is Mercury not a dynamic happening place? Its name is almost synonymous with quickness in a lot of ways. Mercury was a messenger god in Roman mythology, but the surface here is pretty chunky and rocky. It doesn't move much at all. Pretty much the most exciting thing to happen on Mercury would be something falling and hitting the surface. You can see where that's happened before. All of those dips and dots all over are craters where something has fallen and struck the surface, leaving behind one of those dents. Sometimes when a really big thing hits the surface, we get to see some more exciting shapes than just a little dent. Check out this guy right here. Notice that dot in the middle? Now, I'd want to double check this to make absolutely sure, but I'm willing to bet that's what happens when a large object falls and strikes the surface. There's actually a little bit of splash up in the middle, making a mountain inside the crater. That's kind of cool. Other craters show us some interesting signs as well. Like, check out this thing down here. That's an oblong crater. It's possible that's two different impacts, kind of like we see over here. Or maybe something came in at a strange angle and left this behind. But check out these lines coming off of it right over there. It's what we would call ejecta, material from inside Mercury that gets flung across the surface, dust pretty much. Why isn't it blown away? If that's an impact that's 1,000, a million, maybe even a billion years old, but that might be stretching it. Why isn't the dust blown away? There's no wind. When we look at Mercury, activity comes in a lot of forms. It could be liquid moving on the surface. It could be air moving around it. It could be almost anything moving around. Rocks don't move that quick. And since there is no air, there is no liquid, just rocks, we see it as a static place, a place that's pretty much unchanging. But that doesn't mean boring. For example, I just found something really strange. Check this out. There's a crater with a perfect crater right inside it and a little crater on the edge. Kind of looks like a belly button or something on the surface of Mercury. That's one of the coolest things about OpenSpace. You will find things you've never seen before. You will find things you may have heard of. There is some really cool stuff hanging out here. Sparkle's asking about the asteroid belt. I think that sounds like a really cool thing to check out. Brand new OpenSpace can show you the asteroid belt and all these cool particle effects flying around the sun. I haven't updated because our engineer is busy, and getting it installed on my home computer has proven a little challenging, but I have a good consolation prize. There is a big thing hanging out in the asteroid belt. That is the dwarf planet Ceres. Now, Ceres, a little bit like Mercury, is a rocky thing, but Ceres might have a bit more activity going on underneath the surface. When you look at the surface, it looks pretty much the same, gray with rocks. Now, some suspect that this is a watery object and that there could be an actual liquid ocean under the surface. Maybe it's frozen. Some people seem to think it's not. In either case, we aren't going to be able to tell. In fact, we aren't going to be able to tell for quite a while. We would need to send a spacecraft to very carefully measure what's going on at the surface and maybe even dig in before we could state confidently that there is or isn't a liquid ocean inside Ceres. Some of the best evidence we have for it, though, can actually be seen right around the equator of this object. So let me fly around over to here. And as Ceres is flying past, we're going to turn off the nighttime. Check this out. Now, this stands out for sure and may actually be an active place on the surface. Inside this giant crater, we can actually see some of these deposits on the surface. These are probably something like Epsom salts. There's been a lot of guesses, a lot of estimation about what we're actually seeing here, but that light material is super noticeable. We even saw it as we were flying up to Ceres, but it probably is something water soluble, and that might mean it's getting deposited on the surface by liquid water moving around. Are any planets in our solar system presently being hit by asteroids? Daniel wants to know. All of them. In fact, we get hit by tons of stuff. I should qualify that. To be an asteroid, you've got to be bigger than 10 meters across. That's a 30-foot long object for us Americans. That's a big one. We don't get hit by those all the time, but we get hit by them not infrequently. We think we should get hit by a good-sized asteroid about once every 1,000 years, I think. Now, Earth got hit by objects from space today. I'm pretty sure we got about 100,000 tons, I want to double check the zeros on that, of stuff getting added to our planet. It's about a full-size adult blue whale. That's a lot of stuff, but it didn't come as a single object. It came as teeny tiny objects filtering down. Sometimes something big will slam into Earth, and then we get to see cool fireballs. If any of you saw some of those really cool comet shots, people have actually caught a couple sizable fireballs while they're out taking photos of the comet. That's like a twofer, a great option. Lara wants to check out Phobos and Deimos. Those are some of my favorite things to see. So you can talk about this again as sort of an asteroid story, a near miss, as it were, because instead of slamming into Mars, these two objects were traveling at just the right speed to get captured by Mars and turn into the two Martian moons. Now, Earth's moon formed around Earth. We are almost completely certain of that fact. When we talk about Phobos and Deimos, Phobos may have formed around Mars. We've talked, last week, I think, about how it might have formed. An object that was puffy and slushy, a whole bunch of debris, basically, a ring around Mars, condensed to form this single object, but it's small. Now, this is a captured object, most likely, at some point in the past. An asteroid from the asteroid belt wandered in a little close, got snatched and stuck gravitationally, and it's been hanging around Mars ever since. But if we get a little closer, so you can still see the model there, and we look towards the planet Mars, that's pretty big, right? If you're standing on the moon, Earth does not look that large. Now, that's because these are very close orbits. They hang out close to the surface of Mars, but that also means Mars exerts a pretty strong gravitational pull. These moons fly around Mars every few hours. I think it's about 8 hours for the inner one, Phobos. That is super quick. Now, when we talk about a month here on Earth, it's about the same amount of time as it takes our moon to travel around us. When we're talking about a moon of Mars, imagine having a month every 8 hours. Deimos looks very similar, a little rounder, but still that kind of irregular, lumpy shape, like a potato. So we often call them space potatoes as captured objects. Mars itself has a lot of cool stuff going on. Ooh, Enceladus. Corey is killing me. Enceladus still, I can't get to work on my computer, but there's opportunities for the OpenSpace folks to help us out and get some assistance with getting our icy moons up and running. Alas, I still cannot show you Enceladus. Looking around on Mars, though, we can see some similar attractions. Let's check out up north on Mars. You should be able to see a whitish area. That's one of our ice caps. Now, ice on Mars is a pretty exciting thing. Whoop, there we go. That's our ice cap right down here. When you see ice on Mars, this is a deposited icy structure, and they do fluctuate with the Martian seasons. Mars goes around the sun about once every 2 Earth years. And because of that, we get a chance to see these slight variations in the ice caps, showing us where ice is being deposited. If we fly down to our other ice cap, way down here, that was actually the southern cap, I believe. Our northern cap seems to be more towards the sun, and that probably means it's dissipated, spread out. But when we look at those ice caps, it's not entirely water ice. In fact, it's probably mostly carbon dioxide frozen on the surface. Think about that. Same stuff you are breathing out as a solid. Okay, Hillary and Aiden want to see Venus. We were talking about active places versus static places. Which one do you think Venus is? Is Venus a place that's always changing? Or is Venus a place that's always pretty much the same? It's a tough question. If you think Venus is an active spot, you're right. If you think Venus is a static spot, not changing, you're also right. I would say the outer part of Venus, the atmosphere we're looking at, is always changing, always moving. There's a lot of motion there. So when we look at Venus, we can usually see different kinds of clouds, different structures, different patterns on the cloud surface. But when we look at the rocky surface below, that's when things get different. The rocky surface doesn't seem to change a whole lot. There are volcanoes that might smooth out some spots. There does seem to be some active volcanic activity is a bad sentence, but some volcanic activity on the surface of Venus. Yeah, but maybe not enough to completely reshape it. Sort of like Earth, there might be a little bit of motion over time, but Earth is a much more dynamic planet with a lot more moving rocks than our friend Venus. But that doesn't mean Venus is boring. Kind of the opposite. Venus would be a very exciting place to visit, kind of challenging. Well, as soon as you landed your spaceship, you would have a struggle on your hands because the surface of Venus is about 900 degrees on the Fahrenheit scale. So Aiden, if you are planning on visiting Venus, you're going to need a tough spacesuit, something to keep you nice and cool. There are other challenges too, like being on the surface of Venus would be like having a weight on top of you that would be incredibly heavy. It's like being a kilometer, under Earth's oceans. You'd be getting squashed. Now, as if that weren't bad enough, one last horrible thing, it's highly acidic. Nora wants to see Saturn. I think that sounds like a wonderful plan. We are heading far out from our sun, almost a light hour from our sun, to go visit Saturn. When we talk about distances in space, using miles or kilometers gets really, really tough to do. Earth's about 93 million miles from the sun, but it takes light about 8 minutes to get to us from the sun. So if the sun suddenly turned plaid, we wouldn't know about it until 8 minutes after it happened. Saturn, you'd have to wait a whole hour. Now, that's a change for sure. Waiting that long means that we get a significant amount of delay between the inner and outer solar system if something like that were to happen. Now, the sun doesn't turn plaid, but it does have solar flares. It does have momentary changes, and that light travels away from the sun at the speed of light. So when you look at the light that is bouncing off the rings of Saturn, right now Saturn's about the opposite direction from the sun from us. We're right between Saturn and the sun. That leads to kind of a cool math problem. I'm not going to tell you, but if you think you have the answer, write it in the chat. Light goes and travels an hour to bounce off Saturn and its rings. And then it's got to reach us here on planet Earth. How old is the light by the time it bounces off Saturn and hits us on Earth, provided all the planets are basically in a straight line? If you think you know, write it in the chat. I would love to see whatever answers you folks have. We can prove to ourselves that those rings are being illuminated by the sun, because check out over here. That dark spot is where Saturn's shadow is falling on the rings. And since the rings are circular, they do the same thing to Saturn. You can see right down here, those shadows of the rings hitting the surface of Saturn and proving to us that as perfect as those rings look, they're not quite perfect. They have little tiny irregularities, changes in their height and distribution that make that cool, funky pattern on the surface of Saturn. And that rhymes, and I didn't mean it for it to, and that's great. Okay, zooming away from Saturn, Sharon's got a request for Neptune. This sounds like a lovely idea. Let's go check out Neptune. And again, if you have another idea about where we should be heading, throw it in the comments. I love your suggestions. Continuing on, away from Saturn out to Neptune, we are getting super far from the sun. Neptune is the farthest planet from the sun, given our cursory definition of what a planet is. Pluto doesn't count by my current definition of planet. When we look from Neptune to the sun, it's almost hard to spot which one the sun is. Here's a hint. It's the one that's casting our best shadows. When you're looking at the surface of Neptune, though, what do you see? Now, to me, the first thing I always notice is color. That beautiful, rich blue. It's not a fake color either, not a scientific illustration. What we're actually seeing is the actual color you would see, not enhanced color, not translated color. It's just that blue. Not all parts are equally blue. Some spots are darker. Some spots are actually lighter, too. You can see some of those puffy white structures. We had a question last week about the diamond bergs floating around inside it, whether or not those are real. I looked it up a little bit. You can say that this is carbon. You can say the carbon is probably floating around in this sea of other materials. It is probably under a lot of pressure and therefore might have an increased temperature. But here's the really cool part. We don't know exactly what's going on inside Neptune. We don't know exactly what's going on inside Uranus either. There's a huge amount of our understanding of the interior structure, the insides of these planets, that's just a giant guess. Now, when we find a planet like Uranus or like Neptune around another star, we would love to know what's going on inside there, but that's really challenging until people go out and do lab work, experiments at universities and scientific institutions that helps us understand how light and pressure and chemistry all interact with each other inside these worlds so that we can really understand what's going on there. Ooh, Sparkle's got a good suggestion. Let's go spot a face on Jupiter. Now, as a kid, one of my absolute favorite things to do was, while it was bright outside, lay down and look at clouds. When you look at clouds, sometimes you can spot all sorts of interesting things popping out. I mostly did this during soccer practice because I'm really not good at soccer. But when we are looking up at those clouds, there aren't actually bunnies or rabbits or cows or pigs floating around up there. It's just structures that are completely random. When we look at Jupiter, you can see some kind of similar stuff. So I would challenge you, before we go and point out that face, find something else. Find something you can see on Jupiter that reminds you of something else. Now, I might be able to get us started off. Looking around on Jupiter, I can see, ooh, I got a good one right here. I'm going to turn us upside down. I see, there's no up in space, so upside down is totally subjective, a snail. Can you see it? There's his long neck and an antenna and his swirly shell. If you can see something else, put it in the chat. Looking at clouds on another planet is a super cool thing to do. If you have a backyard telescope, Jupiter is about as bright right now as it's going to be this year. Point it at Jupiter, and if you can, try and pick out those dark bands. This band right here and this band down here. When you see those, you're actually seeing clouds on another planet, and that to me is just the coolest and most exciting thing. So again, if you have any shapes you can pick out, or any weird structures you see on Jupiter that I didn't mention, throw those in the comments. I would love to see what you folks are imagining. Here you can see a nice white spot. Jupiter also kind of reminds me of when you drop cream into coffee, you get those swirly whirly effects. Now, I don't see our cool face on the side of Jupiter that's lit up, but if we turn off the nighttime side, we can actually see the entirety of Jupiter like it was glowing. Jupiter actually does give off a tiny amount of infrared, but it doesn't give off light like this. Ooh, I see the big red spot and those crazy storms around it. People see a dragon. That is super cool. Now, spotting a dragon, I think anytime you're spotting an imaginary creature, you get a lot of leeway about the distribution and anatomical features of it. That's totally fair. But I'm imagining sort of the maybe Asian-style long, windy dragons on these ones. I think that's a pretty cool look. Okay, so looking over here, can you see our face? We've talked about it before. I think that's what Crystal might have been mentioning. You can see here one googly eye, another googly eye, and a weird monster mouth. Kind of looks like a Muppet, maybe, floating inside the clouds of Jupiter. How about that great red storm? I just saw a cool one. Check this out. If that's the eyeball, and that's the beak right here, it looks like a baby chicken yelling. Okay, zooming away from Jupiter. Give yourself some time to do some cloud gazing on another planet. It's just a fun way to pass the day. A lot of us have extra time right now. Oh, I love showing you the constellations and how stars in the constellations are not on the same plane, but are far away from each other. Well, I've accidentally flown us so far away that we might as well go check that out. So right now, you can pick out our sun. Our sun is right there, that glowing sphere. And when we zoom back, let's find a familiar constellation. Right there. Can you see our Big Dipper? Right there. Well, hold that on your eyes. 1, 2, 3, 4, 5, 6, 7, 8 stars. Okay? And now check this out. As we zoom away, you'll start to see the Big Dipper is changing. Right about now. Can you see it? All of a sudden, it got flatter down here. And if I keep flying us backwards, it's going to keep getting flatter, keep warping, keep bending. Can you see the Big Dipper still? I see 1, 2, 3, 4, 5, 6, 7. But the farther away we get from home, the weirder that constellation looks. In fact, from out here, I can see 1, 2, 3, 4, 5, 6, 7. It's getting bizarre. And it turns out the farthest away bright stars of the Big Dipper are not that far at all. I think it's right there. Now, when I say not that far at all, astronomers have weird ways of talking about distance. When we go out to here, you can start to see the distribution of stars around us. There's a lot more on this nice flat shape than there are above or below it. That's actually our galaxy. When we look at our galaxy, there's a ton of stars in the disk. There's not as many above or below the disk. The concentration of stars really is in that disk of material, and that's where we find a lot of our brightest constellations with the most stars, because that's where the most stars are. Okay, so we're zooming back in. Let's see. We've got a couple minutes left. Any more suggestions out there? Now, we talk about Pluto a lot, and I actually would like to give us a little bit of a reprieve from Pluto and go visit the rest of Pluto's boy band. The one hanging out next to it is Charon. Now, Charon, you can actually see really well in the OpenSpace imagery because this is taken from the New Horizons mission. Looking around here, you can see all sorts of super cool, super interesting features on the surface. Dark spots, light spots, even this kind of rectangular dark spot that's called the Mordor Plane. And over here, you can see some of the light spots are named for characters from Star Wars and Star Trek. I think those might still be provisional names, not the official ones yet, but they might get approved, and that to me is about the coolest thing around. Charon is a really interesting place. Now, looking from the surface of Charon, you can actually see Pluto right over there, kind of like we saw Mars. Well, Phobos and Deimos zoom around Mars super fast. If you hung out on the surface of Charon, you would never see Pluto move. It would just hang out in that part of the sky. I saw a question pop up about seeing other galaxies. Yes, we can see other galaxies, but because I wanted my computer to run quickly, I didn't load up all the other galaxies that exist in OpenSpace. If you want to do a lot of cool galaxy exploring, you should check out OpenSpace for yourself. But in the meantime, I can show you one galaxy at least that is visible with our own two eyeballs, and that is the Andromeda galaxy. Now, to find Andromeda, I'm going to go, there's our Big Dipper, use my 2 cup stars to point to Polaris right there, and then on the opposite side of Polaris, from the Big Dipper, we should be able to spot this little W of stars, Cassiopeia, and then right there is the Andromeda galaxy. I'll call that pretty good for a called shot. Let's see. Ooh, folks want to check out NEOWISE. I can tell you, I am not an expert comet observer. I have messed up seeing so many comets in my time as an astronomer, but this one is actually obvious enough for even me to spot. So I hope all of you get a chance to go out and see it. If you want to see it, it's actually an evening object now. So what I would recommend is going out to a spot where you can see the sun set. Let the sun go down and then comb that part of the sky for our comet. It's just zoomed past the sun and is moving farther and farther out. If you want tips on exactly where in the sky or which constellation you should be looking at, I would say tune in tomorrow and ask Bing. He can show you in those constellations exactly where you should be looking. I think it's next to a relatively faint constellation called the Lynx, but will actually be underneath the tail of our Big Dipper in the next few nights. Okay, so that means our comet, from a three-dimensional perspective, I can actually do this part a little better, has zoomed in around the sun and is going to be coming back out. Now, that's a pretty cool time to see it. While the comet is closest to the sun, we should be seeing it at its brightest. We should be seeing that beautiful tail stretched out, which is actually pretty noticeable. It's unique for me. I've not seen too many comets with actual good tails. But something that is the space coming down and being visible for us, seeing something travel at incredible speeds through our solar system is always super cool. And a good comet like this doesn't happen very often. Give yourself the opportunity to see it and check out the other bright planets. If you wake up or stay up late enough, you should be able to see Jupiter, Saturn, Mars, Venus, and soon enough, Mercury too. We live in a solar system, and that's always a nice thing to remind ourselves of, that we are watching our solar system happen in some really cool, really exciting ways. I recommend giving yourself the opportunity to engage in our solar system and observing it in that really awesome way. And you're not going to get another chance at this comet. I think it's going to be back in several thousand years after it departs this time. With that, thank you all for joining us. And if you have the opportunity, tune in tomorrow or Tuesday. We're going to have a really cool youth program. On Fridays, we have our Cosmic Conversations, and this time we're bringing in folks from the SETI Institute. That's the Search for Extraterrestrial Intelligence. They're going to be talking about our super cool New Horizons mission. But from the Morrison and the Academy as a whole, thank you all for joining us here. We hope you can all stay happy, safe, and healthy. We'll see you back at the museum sometime soon. Have a great day.